Welcome to the session for Gd&T for Design and Quality Engineers. In this session, we are going to see the datums, modifiers and symbols. Datums. Datums are the reference surfaces or the starting points for the location and orientation features. They are essential for appropriate and complete tolerancing of a part. Datums are theoretically perfect points, lines and planes. They establish the origin from which the location or geometric characteristics of features of a part are established. These points, lines, and planes exist within a structure of three mutually perpendicular intersecting planes known as a datum reference frame. This is datum reference plane made up of mutually perpendicular planes. These planes are xy, yz and zx. The main function of datum reference plane is to specify a foundation for the inspection of the part. It is the common coordinate system of all tolerance zones. This is a chart specifying types of Gd&T. This consists of symbol, characteristics, categories. There are 5 types of categories: form controls, orientation controls, location controls, runout controls, and profile controls. We will see one by one. This comes under form controls. Straightness. Surface straightness can apply to flat surfaces like a side of block or curved surfaces like a side of cylinder along the direction of the axis. Next is flatness. We use the characteristic for features such as the face of part. The symbol for flatness is a parallelogram tilted to the right. Next is circularity. This characteristic is shown as a circle in the first compartment of the feature control frame. It shows how close the circumference of the part should be to be perfect circle. Next is cylindricity. Cylindricity is basically in 3D meaning that it runs along the whole length of the part. This comes under profile controls. Line profile. Line profile establishes a tolerance zone around varying 2D cross-section of the parts. It controls individual line elements of a part feature. Next is surface profile. Surface profile control is more popular compared to line control. Instead of a two-dimensional tolerance zone, the surface profile control creates a 3D zone around a surface. This comes under orientation controls. Angularity. The angularity control keeps the angle of a feature with respect to the datum in check. We can use it to control a 2D line, but it is more popular with keeping surfaces under control. Next is parallelism. Parallelism is a refined form of angularity. Here, the datum is the surface we need to imitate and the angle is set to 0 degree. There are two types of parallelism. First is surface parallelism and second is axis parallelism. Perpendicularity is also a specific form of angularity where the angle is set to 90 degree. This comes under location controls. Concentricity. Concentricity is also known as coaxiality. That control maintains the concentricity of a circular as well as cylindrical features. Next is the symmetry callout establishes a central plane around which the two parts of the features are placed at equal distances. The midpoint of the 2 points on either side must lie within the tolerance zone set around the central plane. This comes under runout controls. First is circular runout. Circular runout works in two dimensions to control the form, location, and orientation of various part features. In Gd&T jargon, circular runout is known as a runout. Next is total runout. Total runout is the 3D counterpart of a circular runout. It controls form, location, and orientation as well.